Good to meet everybody. I'm Vikram Chatterjee. I'm the co-founder and CEO of a company called Galileo. Galileo is the leader in AI and agent observability and guardrailing. And we started about 4.5 years ago. Before that, I was heading product management at Google AI, not too far away from here, specifically focused on language models back then. This is circa 2019, 2020. So back then, it was called deep learning. It wasn't as talked about as it is today. But Galileo has been in the space of building out observability for developers working with language models for the last 4.5 years. So kind of seen the entire gamut of how things have changed from the earliest language models to where we are today. So super excited to have this chat about trust.
Awesome. Hey everyone, my name is Samir. I'm the co-founder and CTO of Deductive AI. Deductive AI is a company that we started about 2 years ago. And the whole kind of genesis of Deductive AI was to apply reinforcement learning to observability. So the idea is that how can you kind of basically train the next generation of RL-based agents that can actually mimic the workflow of an experienced engineer or an SRE, so that you can actually basically look at systems at runtime, debug them, and kind of hopefully even kind of essentially fix it. Before Deductive, I was leading large-scale query engines at Facebook. These were the set of teams that were powering our company's SQL, machine learning, and observability stacks. And before Facebook, was one of the founding engineers at Databricks. Spent a lot of time there leading the open source Apache Spark team. So a lot of my background has been in traditional databases, the query engines, the optimizers, the runtime, and things like these. And before all of that, received my PhD in databases from UC Berkeley. Was very fortunate to be advised by Jan Stryka, and did research at the intersection of databases and reinforcement learning.
That's awesome. Quick introduction on my end. My name is Vedant. I work at a fund called Premji Invest. Premji Invest essentially is a very large fund. We manage about 16 billion in assets, and we invest from the Series A to pre-IPO. We do a lot of enterprise software and healthcare investing here. We're investors in companies like Hippocratic, Ryder, Runway, Hugging Face, Space 10, Galileo, and a whole host of other enterprise software companies in the past. Let's dive into the topic. Maybe before we start with engineering trust at scale, which is really the theme of this topic today, I'm curious because both of you come out at the AI space with very different vantage points, right? Like Galileo basically says, hey, I can tell you if your application is hallucinating or not, and then how do you go fix it? And then Deductive says, hey, if you have an issue with your application, whether it's AI or not AI application, then I'm going to figure out what was the root cause and then maybe a patch for it as well. But in essence, both use AI for AI in a way. So curious, what does the software application or the AI application of the future look like?
Okay. I'm a bit biased because even when we started Galileo at Google, the big hypothesis behind why we were so focused on unstructured data-powered AI back then was because we had seen this huge transformation happen at Google where Google Translate, I don't know if folks remember this or not, but this is really famous when Google Translate had tens of thousands of lines of code from a software engineering perspective. And then as soon as BERT came out, they wanted to have Google Translate be the biggest application powered by BERT. And it came down to just 500 lines of code, and everything else was intelligence, right? The fine-tuned BERT model. So that was such a big, powerful moment and a wake-up call in the community to basically usher in what we all started calling software 2.0, where it was very clear that the future of software is going to be AI. So AI is going to eat up software, right? So when I think, to answer your question about what's the future of a software app, where every app is going to be an AI app. There is no more software engineering, quote unquote, the way we think of it today. Two things I think are fundamentally going to change. One of them is going to be, which you're already seeing change. One is the expression of the language that developers use is going to fundamentally change. It's already getting simpler and simpler with Python and things like that, which is almost like English, to actually using natural language. So that's going to happen, which is going to massively democratize how many people can actually build our applications, right? Like my parents build software apps now in their 60s and 70s, which they couldn't have done even a year ago. So I think that's one thing which, if it's happening now, imagine what's going to happen in 5 years. The second thing is, I think from an expectation perspective, there's a new primitive in the form of intelligence that's come in. So the future is going to be the next generation of folks, of kids even, when they play the next video game or they're using the calendar app, I think they're going to expect it to be smart and have memory and learn over time. If that doesn't happen, then it's just going to be a no-go for them. So I think those few expectations are going to change in the future.
I think like just basically plus one on both the points. Like what we see also is like essentially just this whole democratization of like who is writing and creating the software applications. Definitely, like I mean, basically there are the technical people and the non-technical people, but like even within like the technical kind of like essentially setting, we are seeing that the roles of like different people who are kind of like building software are converging. Like we have like software engineers, software site reliability engineers, DevOps, like I mean, product engineers, product designers. Now we are increasingly seeing like I mean, this is happening literally within Deductive and even kind of like outside to many of the customers that we are working with, the roles of how like software is getting created is kind of like increasingly getting fuzzy and kind of like essentially intermingled with like these kind of like so-called static boundaries. And Vikram, to your point, like I mean, effectively these kind of like software systems that are getting created, they are a lot less predictable now. They are a lot more intelligent. They are kind of like essentially adapting to human behavior, and as a result of which, like essentially a lot of like traditional ways of testing these systems, which used to kind of like basically be about static unit tests, static kind of like integration tests, and all these kind of things, are by definition also evolving. So these are kind of like some of the nuances that we are seeing.
Makes sense. I'm curious, these large frontier models are both, I would say, maybe a boon for both your businesses. If you didn't have these LLMs, you wouldn't have probabilistic responses and you wouldn't have hallucination. And if you didn't have LLMs, then it might be hard to also build like a root cause analysis app built on top of it. But it's also a bane on the other end, because there's all this talk that these models are getting better and better, and intelligence is basically asymptotically reaching zero. Question for both of you, maybe we'll start with Vikram first. If models do get better, let's say we fast forward 5-10 years from now, and there was this recent OpenAI paper on, if we train models differently, maybe they hallucinate less because then they're just not guessing anymore. If models get better, then do hallucinations go away, and then do I not need to either do evals or do observability on top of my AI applications?
I think, so there's two parts to this. One is models will keep getting better, 100%. And in fact, when we started the company 4.5 years ago, it was under the premise that these language models will get bigger and better over time. We just didn't expect it to happen so quickly and so rapidly, and so much money getting poured into this. Model, what I call this model flexing, where there's like, BERT model came about, and then there was coal BERT and a distill BERT and a bunch of others. And now then billions of dollars were thrown on models, and now they're becoming bigger and better and faster. That being said, the core primitive is still going to continue to be probabilistic, because there will still be weights. Those weights will still get multiplied by the vectors. They will be, the output is going to be a series of probabilistic output tokens, and so that's going to continue to be the case. So number one, at the heart of it all, at the end of the day, even if it's an absolute AGI accountant, right, like it'll still be probabilistic, like a human being. Couple that with the fact that in the enterprise, in an actual use case scenario, you have a lot of context around in your company for your use case, for your private data. An application has to operate in a certain way. And in that scenario, a model by itself is just one of many different entities. And so in that scenario, and we can talk about this again, like it's what we're seeing today is already these applications are compound AI systems, where the model is the core operating system. And even if the operating system starts becoming better and better, there's this whole ecosystem around it, which is why, again, like the core premise is AI will eat up software. And so there will be no Datadog in the future. Datadog of the future will have to be an AI observability company, which is what Galileo intends to be.
Makes a ton of sense. So question for you on, similar on the same lines of models getting better, and maybe echoing Vikram's point on, you still have compound systems, and if you have 1% error also, then maybe it's still cause for concern, and you still need a evals observability solution. From your vantage point at Deductive, you guys write code, right? Lots and lots of code to find root cause for why something went wrong and then go and fix it. Your solution's obviously benefited by some of these AI agents or these AI coding apps getting better and these models getting better. But if I can stretch this to an extreme, say my Claude code or my Cursor gets really, really good, and I'm writing near perfect code, then do I need to ever do any sort of root cause analysis? Because maybe I just don't need, maybe I just don't have any bugs.
Yeah. No, that's a great question. So the way that we kind of like basically think about this space is like ultimately it's a context problem, right? In order to kind of like essentially if you think about code generation and in some ways like code understanding and observability and this kind of like whole space, instead of like thinking of two ends of the spectrum, I kind of like to think of this as a contextual problem. So ultimately the question here is, when I'm writing code, if I have access to my telemetry data, would I be writing better code or not, right? If I similarly am debugging code and if I have access to my code base and the ability to kind of like make changes in the code base, will I be able to debug better or not? So the way that like at least we think about it is like it's less about like, hey, a model is generating code and like, I mean, there is some other model which is kind of like looking at the telemetry data. We kind of like think of this as part of the same equation. So ultimately when the model gets better, you are by definition going to write better code because you will not just have to have access to the code itself. You will have access to all the telemetry data at runtime, at development time. And then similarly, like as models are getting better, your ability to kind of like actually understand general purpose code and kind of like correlate it with all the telemetry data is also going to be better. So that's kind of like one way to think about it in our world. The other nuance I want to kind of like also call out is that, and this is something that we are increasingly seeing as well, like in a world in which software is actually increasingly getting written by these models, and definitely these models are getting better and better, two things are going to happen, right? Like, I mean, definitely a lot more software is going to be written. And the second thing is like a large part of this software, like we are right now talking about like 20, 30% in most companies. This number might actually grow to 50%, 60%, 70, 80%. A large part of like the software that is going to be written in the next like 10, 15 years is going to be by nature opaque. So maybe the complexity of the issues will increase. They might get fewer in number, like because maybe the models actually are not going to make like the standard kind of like, let's say, null pointer exceptions that they're kind of like right now prone to making, or maybe some of these things. But like when systems break, we might actually require a lot more effort to debug them as opposed to like what we are doing now.
Yeah, so basically what you're saying is the puck shifts or the bottleneck shifts. Today we're saying, hey, listen, we still need SREs, we still need to go debug software. Tomorrow, code will be ubiquitous. Everyone's going to be able to write code, but the code is opaque. No one really knows what's inside it because some AI model went and wrote it. So
right.
You're not necessarily saying that the bugs go down. Maybe the bugs go up depending on how some of these systems got written. And you're also saying that if you have access to telemetry data up front, maybe then you also, maybe you change the equation a little. So that it makes a ton of sense.
And one nuance here I want to just kind of like call out is that like, and this is like an interesting one. Like if you think about it, right? Like ultimately, code generation and kind of like healing software is like both sides of the same coin. Like if you have a single-threaded web server, and like suddenly you have like essentially, let's say 10x the load, like and there is a piece of system that's kind of like healing itself and like making it multi-threaded. Is it like an RCA problem or is it a code gen problem, right? I mean, the line is very fuzzy, and this is why like essentially I think like it ultimately boils down to a context problem that you need to kind of like go and evaluate on.
Fair enough, makes sense. I want to change gears a little from models to evals, right? And how do you measure basically if your application makes sense or not? Vikram, obviously Galileo is in the business of pre-production, trying to figure out if your application is actually working or not, and then post-production actually monitoring it in real time, and then having some sort of guardrailing. Maybe for the benefit of everyone in the audience today, can you just walk us through what is it? How do you evaluate if your AI application is working or not? Like, is it vibes or is it something else? Like, what is this new paradigm?
Yeah. So for everyone, I don't know how familiar you are with the term evals. It's basically become a new term now. At least started in the Valley and now probably globally. But essentially, at the heart of it is basically it's just like you have in software development lifecycle. You had tests and QA. It's the same thing in my head. It's like, how do you create these different kinds of tests for your AI system? The only difference is in traditional SDLC, these tests would be very hard-coded, very simplistic things, which almost can be automated from a creationary perspective. In the world of AI applications, just given how non-deterministic these things are, the kinds of tests that people create have to be based on certain metrics that you build out. As an example, if you build a RAG-based application, you have a lot of context. You have to build out a test for, let's say, adherence to that context. You have to build out a metric for that, first of all. And then based on that metric, you build this test, and that test becomes a part of your CI/CD pipeline, et cetera. So that's what an eval is. And the power of a software app is basically dependent very much, or the success of that agent or AI app is very much dependent on the quality of your eval. And that's the part which everyone's grappling with today, where most teams that we talk to, even some of the fastest growing startups in the Bay Area in New York, when I go and talk to them about how are you evaluating your applications? It's being used by millions of users today. The answer is mostly vibes. Most people are just crossing their fingers and hoping for the best until something breaks and there's headlines. That's good press for them. But then they go back and they have to fix that, and that's when they can start to get serious about this. And but when we talk to enterprises, they can't launch anything unless they have tests in place. That's where we typically come in, because the way you write AI tests is very different than the way you write traditional software engineering tests.
Makes sense. Maybe like flipping it back then on deductive. You guys are an AI system that does this, RCA analysis and SRE work. How do you do evals today?
Yeah. So we kind of like basically look at a combination of like online and offline evals to kind of like evaluate our stuff. Like, I mean, ultimately we are in the root cause analysis business, right? Like, I mean, just to kind of like intuitively think about root cause analysis, it's a sequential kind of like decision-making task where like you're trying to kind of like take certain action, you're kind of like seeing how that action's kind of like output is, and then you're trying to take a next action based on this. Eventually, the goal here is to find out like the possible problem that kind of like led to breaking the system. So for offline evals, like, I mean, one of the most important part for us is to kind of like actually look at what the ground truth is, right? And this is like essentially an interesting problem in itself, because if I'm kind of like, let's say, deploying in one customer account, I have to kind of like look at all the kind of like alerts, root causes, like, I mean, all the problems that has happened in their kind of like basically company for the last like many, let's say, months or years, to try to kind of like generate that ground truth data. So that's kind of like an important aspect of us to kind of like get right. Once we have that ground truth, then we can kind of like basically run offline evals, which is effectively like essentially a fancy way of saying that we compare the output of like what our agents are generating and kind of like compare it with the ground truth that we have. So that's kind of like one aspect that we kind of like have really kind of like consciously been thinking about. Definitely establishing this large corpus of ground truth is like essentially a very hard problem, and we pay a lot of attention to it. The second aspect for us is online evals. So while the investigation is actually happening, there are a lot of like indeterministic kind of like parts of the system. Like it might kind of like go into certain kind of like, let's say, deep investigation, and maybe it's kind of like not really making any progress, right? Like, so at any kind of like runtime, you have like given kind of like inference time budget to kind of like basically nudge your system and kind of like focus your energy onto like the right kind of like pieces of system and things like these. And for that, we basically use online evals. So every step that our agent is taking is effectively like assigned a reward if it's kind of like finding something useful. And then anything that like the agent is doing, which is kind of like unnecessary or kind of like potentially harmful, is penalized. And these kind of like basically reward and cost functions are then fed back to our learning loop. So that like the system kind of like improves over time. So this is like the two ways that we are kind of like basically looking at this problem. Definitely human in the loop kind of like aspect of it, or getting the humans to annotate this data, is an important aspect of it. But admittedly, like we have not been very successful at cracking that kind of like entire problem, because like, I mean, essentially getting humans to give feedback on like basically something that like essentially a tool or agent is doing in a way such that it's very non-intrusive is a very kind of like interesting problem. So it would be very interesting to hear about like essentially how different people are thinking about it.
Are you guys using each other's products? It feels like you guys would.
Great matchmaking exercise.
Absolutely, yeah.
Are you sure? It feels like you can prevent vibes on one end, and you can prevent a bunch of human beings trying to find root causes on the other end. It might be a win-win.
Sorry, just to interrupt for 2 seconds. The title, it's really about trust, right? In general. I'd like you actually just to respond to the questions. We are in this chaotic, non-deterministic, it's probabilistic. Whatever you do is going always to be like problems there. How would you trust this thing at scale?
Yep.
So sorry, just.
Yeah. We were going tangentially around trust, but basically, I think maybe I'll answer it and ask this question in a different way. But essentially, with trust, in my view, you need to trust if your AI system works or not. And then you need to trust that when it breaks, you can get to the answer as quickly as possible, so that you keep your system up. There's a notion of uptime that I'm sure you guys talk about a lot, and there's a notion of metrics that you guys talk a lot about trust itself. I think it's a question. Maybe let's riff on the trust question a little more. Maybe a question for you, Samir. What is the process by which someone goes and finds bugs within a software application, and then how do they do that process, and then how do they establish trust with their customers that, hey, listen, we have the right systems in place, so that if it's a B2B customer, for example, and I'm serving a large enterprise, like how do I give them the comfort that you can trust me, that I can, even if something goes down, I I can keep it up pretty high?
Yeah, so great question, and I think like you raised a great point. Let me kind of like answer that question in reverse order. So kind of like talk about trust. So I'll try to kind of like give an intuition of how we are kind of like thinking about trust and how we are building our product around that kind of like some core primitives. The main idea that we kind of like increasingly think of is like, hey, how does a human, right? Let's kind of like talk about an engineer who is kind of like essentially hired newly into a company, and they are kind of like now responsible for software development, fixing software, or like being on call. How do they kind of like establish trust, right? And there are kind of like a few different aspects that we need to now kind of like think about. First of all, like when like, I mean, you're kind of like essentially when you think about like this teammate, a good kind of like person who you can trust is supposed to be proactive. Like, I mean, you don't actually have to be told what they need to do, right? They have to kind of like just basically be very proactive about like bubbling up issues. They should never lie, right? Like, I mean, so, and anytime they're kind of like surfacing this information, they need to be like very, like they have to cite their sources, they have to kind of like show them exactly what this work is. And then most importantly, like, I mean, they need to effectively indicate like the sequence of steps that they're following so that like anything that they are kind of like outputting is easily verifiable. Like exactly like, I mean, basically just mimicking that workflow is what we have tried to do like in order to kind of like establish that trust. Now coming to Deductive and how we have kind of like incorporated in the product, first and foremost, like what we do is like we effectively just like when Deductive is integrated into any environment, we first kind of like basically just go into a learning / onboarding mode. So this is like the time where like we just basically try to look at all of their code base, the telemetry data, their knowledge bases, their Slack history and everything. So this is just a means of onboarding, right? I mean, this is the time where we are quote unquote very humble. We're just trying to learn about like their system and trying to kind of like basically just like figure out like what is going on. After that, like, I mean, we basically try to look at some past issues and kind of like some past investigations and try to effectively figure out meaningful insights from those investigations and then try to kind of like basically get more and more opinionated as we kind of like get more and more confidence in the quality of our answers. So what we have seen is like effectively being very helpful in these kind of like engineering flows and not trying to kind of like basically solve the ultimate kind of like, hey, here is the fixed problem like right away is a very good way of building that trust in these kind of like engineering workflows.
And maybe, again, sticking with the question of trust and maybe a question for Vikram as well, help us understand how do internal engineering teams gain trust that their application actually works? Like there's a notion, as we've looked at a bunch of AI companies in the past that you have these compound systems. Let's take a system which gains context from somewhere, gives it to an LLM. The LLM gives you some response. You do an action basis that, and there's a circular loop around it. It feels like if something goes wrong within this, it's like a whack-a-mole strategy that you just go and turn off a bunch of knobs, hope it works, go back the next day, hope it works again. Like, how have you seen the best engineering teams or enterprises that you serve actually trust that, hey, listen, the system actually can work in production?
Yeah. I don't think we're there yet as an ecosystem in terms of any exciting and canonical example of somebody who's actually cracked this. But if you actually go step back a second and look at what we're doing right now with AI in general overall, it's basically at the heart of it all is still machine learning, and the heart of machine learning and data science is that it's unlike software engineering, which is more of you build stuff, you ship stuff, and then you wait for something to go wrong, and then you fix it again. With machine learning, as soon as the cardinal rule in machine learning and data science is always that as soon as you ship something, it fails. It has to fail. Because as soon as it hits the first user input, it's a foreign object, and you have no idea about that, and it's going to fail. So unless you build in the loops, it's not going to work. And the problem is with enterprises that are used to software engineering, and now they're thinking that AI is software engineering, whereas actually data science in a quote, they're surprised that it's not working in production. So when we go and talk to enterprises, we tell them like, look, it's not going to work. Even with Galileo, it's not going to work immediately. But what you need to do is have all the checks and balances in place such that you can build the right tests before you ship, number one. Number two, once you understand what your failure modes are, the number one critical P0 severity failure modes, can you build the guardrails in place such that you can just make sure that the harmful response is not going to your user or the harmful input is not coming into your system. And even then, you're not done. You have to build the feedback loops and automate those feedback loops in order to get there in the first place. So I think there's a learning, and that's happening right now in the industry where folks are thinking that this is software engineering, but it's actually data science. And folks have just lost the science in data science in their almost like the speed to go to market. So that's where we try to ask them to rein in their horses and just know what they're actually getting into.
I like that line. We've lost the science in data science. I know we have a minute and change left. Maybe opening for questions. We have one question. Okay. Go ahead. Yeah, go ahead.
Hi. So first off, I like your analogy, but it's kind of weak tea. I mean, I'm older than all of you guys put together. And back when I started doing software, the thing that was cool is it would fail the same way. And because of the fact it failed the same way, you could go on to do root cause analysis as to exactly what is going to happen and the stuff that's here. The thing about this stuff is it fails differently each time.
Yeah.
And sometimes when it goes on and fails, it goes on and fails in a mode that you couldn't reasonably expect. Is there a way that we can go on and turn this back, using your analogy, to software engineering? That is a mechanism, in essence, where it fails in a very large scope the same way, and it allows us to go on and repair our logic.
I can take a stab at that. I don't think so. I don't think it's ever going to be, because it's fundamentally different than software engineering. I think the genie's out of the bottle on that one, so it's never going to be the same. Yeah, classic machine learning did, but that's why when even with the BERT model at Google, like whenever we launched anything there, as a product lead, my biggest frustration was every single time we launched something, it would continuously fail in new ways, and that's the game of whack-a-mole that Vedant was talking about. And so we think of this as there's a huge amount of evaluation AI research that needs to be done, that needs to be funded in the market, and that's why we've hired a bunch of AI researchers in the company to constantly push the envelope on this. There are many different things that we're doing, but it's all very early stages right now, I think, in the industry. Yeah.
Okay, we have one more question.
I don't need this. Okay, so my question is to echo to the question like that. So I understand the timing is different. So the AI is different than what the old time. So, but the goal is the same. So if you can capture every time you make a mistake, if you can capture what the mistake, and tell the public, so that's also the measure the maturity of your AI, your product. So that should be public, should be regulated, should be shared with the public information, and also your internal improvement.
So publish the error bands. So
Yes.
if it's statistical, then go on and show the statistics.
Yeah. I had just one thought on that. Like, actually, a lot of our customers are using, we build high quality metrics with customers, and what they're doing is they're publishing those metrics to their users. Because it turns out that actually everyone is pretty knowledgeable about the idea that if it's AI, it's probably going to fail here and there, but they want trust in the system. It's almost like if a human being told you, like, if I asked Vedant, like, tell me everything you know about nuclear reactors, and he doesn't know anything. But he gives me an answer, but he tells me that, the truthfulness for this is like 30%. I'll trust him a little bit more than if he doesn't have a metric around that. So it's very similar, like giving the users back like the truthfulness of the actual answer and the confidence score is another part of how you can gain trust with the end user. But apart from that, you have to bake in the reactive and proactive measures inside of your own system, which they never had to happen before in the traditional SDLC process.
One thing I would maybe add to this, like essentially, is that like even though the software that we are creating can actually fail in like very different ways and unpredictable ways, one kind of like thing that we have been kind of like thinking through and exploring a lot is like essentially the sequence of steps that allow us to kind of like ultimately figure out why a set of like software is failing can actually be something that can be quantified and kind of like learned upon. And when I'm talking about like these sequences, I'm not talking about like 5, 10, 20, 100 sequences. I'm kind of like talking about potentially millions and hundreds of millions of these sequences, which can then be learned at scale. And this is kind of like where reinforcement learning as a paradigm is kind of like an interesting one to kind of like keep track of. So once again, it's an unsolved problem and a very hard one at that. But like essentially there is like value in maybe like thinking about that level of abstraction that might change. Like ultimately software can fail in like very unpredictable ways, but the sequence of steps that could potentially be needed to fix or figure out like why the set of like software is failing can potentially be learned upon at that kind of like scale.
Great. Thank you so much. Thanks, guys. Thank you for a wonderful talk.
Thank you all. Thank you.